Hi everyone, I'm going to be going over question 83 from chapter 6 bingo questions. This question has to do with this ice skater who's skating normally at 3 meters per second and then hits this really rough patch of ice that reduces her speed to 1.65 meters per second. And this is kind of an interesting question because it tells us that the friction is equal to 25% of the weight of the skater, but it doesn't give us the weight of the skater. So kind of interesting. And it tells us to use the work energy theorem to find the length of that rough patch of ice. So one important equation is, the work energy theorem. And then also, we want to know the work of the friction, right? Because we're dealing with friction of ice. So that we can write as, and that's the force of friction and the distance. And then we can even expand this even more and say so now we kind of put these two together, and this is what we end up with. So just expanding out these equations, when we expand them out, we'll be able to, see the variables and what we're really trying to go for, and that way we'll be able to plug in what we do have to find what we are looking for. So we know that the friction is 25% of the weight of the skater. And so because of that, we can rewrite all of this, since we have a mass thing in here, and it ends up being negative 1/4 mg d equals 1/2, and then the same here. And so that 1/4 comes from the 25%. And then the mg is just breaking down this force even more. So once again, we're just expanding this. But now what we want to do is we want to solve for d, because that's the distance of this rough patch. So when we do that, we end up, I'll just do it quickly for sake of time. D equals -2 g. Oops. So, like I said, it's just arithmetic, or algebra, not arithmetic, at this point. So, simplify it out to here, and then from here, we plug in the values we have. So, the gravity we know, so -2 over 9.81 times, we know that the final velocity is 1.65. The initial is 3. And when we throw that in the calculator, we end up with the distance equaling 1.28 meters. So that means that that rough patch of ice that slowed this skater down from 3 meters per second to 1.65 meters per second ended up being 1.28 meters, or about 1.3 meters long. This problem was really interesting because we used that 25% weight of the skater, which, you know, I would have never thought to use, and it took me a long time to figure that out, of how to do it, but it's really neat how we're able to take this clue to finally be able to solve for what we wanted. So anyway, thanks for watching. I'll see you in the next video.